I'm an application programmer. That means usually work with financial instruments and portfolios. I manage the calculation core of our software. So what I'm going to present is not what I usually do, but it happened to my work team to play with screen design, and that was fun. We now are part of a bigger reality. We became SimCorp Italiana. I guess you have already heard about that. But to understand our background, I must start from the real beginning. Our product name is SimCorp Sofia. Sofia is an acronym for Software Financial APL. And in Sofia, we create our screens using a screen editor contained in ApplyTDS. So let's see in detail ApplyTDS, how it works. Born in mid-1987, ApplyTDS is the development system used by SimCorp Italiana for internal development. The name is an acronym for APL Italiana Development System. That actually was our first attempt to be independent from the context. The main components of ApplyTDS are a data dictionary, where all the data variables used in the application are described, an overlay system for storing functions and variables, and retrieving them when it's needed, a screen editor for both grid screens and page screens, a set of utilities, so writing code is simplified. ApplyTDS is a layer between Sofia and Dyalog and the operating system. It reduces development efforts, simplifies maintenance, and provides for uniform programming styles and user interface. Thanks to ApplyTDS, our application programmers almost don't know that they're using a QWC to create a GUI object. They don't manage QWS, QWG. A programmer decides that he wants to create a GUI object, and he has to manage almost nothing with the operating system, since ApplyTDS abstracts from it. I should probably say that in Sofia we create all the GUI objects using just Dyalog tools, so not .NET, not C#. And QWC, QWS, QWG are the names used in the Windows version, because they had different name in the DOS version. Yes, because in this period there was DOS. When Sofia was created, the operating system was MS-DOS. In Sofia, the size of grid screens and page screens were always fixed, since they always occupied all the space. To create a grid screen, a programmer just decided which fields he wanted to put into the screen, and the aesthetic appearance was decided by ApplyTDS. To create a page screen, he put fields inside, and they remained exactly where he left them. That's how our young Sofia looked at that time. There was a nice yellow. I think it's a kind of old-fashioned. Well, this is another Sofia. It's Sofia Loren, but maybe more fascinating. A first version of Sofia for Windows was sorted out in 1997. Between 1997 and 2002, programmers used to work on DOS version, and there was an automatic mechanism that kept Windows version up to date. This mechanism tried to reproduce screens in Windows. Obviously, it was not enough. Result was often ugly. So programmers resigned themselves to intervene by hand to put the fields in the desired position. So we continued to have very dynamic grid screens because they were just grids created by AppleTDS, but page screens inherited the rigidity from DOS. This did not create problem in most cases, but we have some screens like our insert order screen in the order register, which need to change and adapt to the user choice. So little by little, a user select which kind of transaction you want to insert, in how many portfolios you want to put that asset kind, and based on each user choice, the screen changes and show fields required to satisfy his choice. So we can have several layouts of the same screen, and for layout I mean that the fields can be arranged in different way, in groups in different way, and those layouts can look really different from each other. Due to the particular rigidity of page screens, a trick to achieve this target consisted in putting all the fields into the screen, all the fields and groups of fields on the screen, and setting visible just the desired fields. As a result, the screen editor was really a mess. To work with this was really impossible, and yeah, we have to do something. And at first, I would define naive attempt to solve this situation consisted in simplify a little bit the screen editor that was less complicated, and in creating a function which was supposed to set field position and groups of field size. But the result didn't improve because the function was too long and boring, and the fields were still in fixed position. So our young Sofia was getting a bit old with rigid features. In the meanwhile, little by little, monitors started to change. They could have different resolution and size. A user could use more monitors simultaneously, and he could share his working session with another user that could have a different resolution in turn. The main problem related to work with a screen that has fields located in fixed position is that it could happen to a user to open it on a big monitor with a huge resolution, and all the fields would have been concentrated in the same area with a huge empty space. On the other hand, by opening the same screen on a tablet, it could happen that maybe not all the fields would have been visible because there would have been not enough space. And that's why we struggled to free screen design from rigidity bonds, seeking to dream up adaptive screen by using a dynamic approach. Our goal was to realize screens able to fit the device that they were viewed on, no matter the size or the resolution, because we wanted our customer to use SimCorp Sofia on any PC or tablet. And that's why we created a script. We created the idea of a script to describe the screen, and we invented a class that manages the script and builds page screen. The script, it's a sketch, it's an outline. It contains information about all the objects contained in the screen. By reading it, the class will be able to draw the screen. So basically, the idea is to use a certain number of vertical and horizontal rulers to split available space in frames, and to organize fields in sequences or matrices in groups inside the frames. So in the script, I will have to define all these objects. I will have to specify rulers and use them to build the frames. And then I will have to describe their contents, arranging fields into groups inside frames. I don't have to specify any size or position for the fields. I will just declare the minimal number of characters. It will be the class that will decide their final size, considering the script and the available space. I can also include some condition to define what I want to see in the screen, which fields I want to be gray, which fields I want to be not visible, and this condition are the switches. So basically, you can just imagine to have an empty space and to use some rulers to split it. So rulers are just function of the available space. I will have some rulers, which some default rulers in the class, which correspond on the edge of the screen. So I will have like, sorry, I just made it wrong. I will have bottom, top, bottom, left, and right. And then I can add some more rulers, because maybe I want to divide the space into frames. And for example, in this case, I used a vertical ruler that is just 1/3 of the space in the horizontal direction, and a horizontal ruler that is 2/3 of the space in the vertical direction. And using these rulers, I build 3 frames, and I put groups inside them, which are composed by fields. And this is exactly how I organize my space into the script. So the class, using the script, will decide size and position of each object, depending on the script and the available space. To define the size of objects, the class uses a depth-first search algorithm. A DFS algorithm starts at the root, or selects some arbitrary nodes as the root, and explores as far as possible along each branch before backtracking. That's exactly what our class does. It starts from frames, because it can read in the script information about the rulers that I used to enclose them. And considering the available space, it can calculate their size. Once the class got the size of frames, it's time to analyze their contents, which can be made of fields, individual fields, or groups of fields. So it pops into each group of fields that the frame consists of and compiles it, popping from the most external one to the most internal one, till it finds just fields. When the class reaches the end of a branch and it finds just fields, it gets their size that it previously got from dictionary and adds separator size. So now the class knows the size of fields and their separators, and this is the time to start to return back. At this moment, each step the class goes back, it takes as starting size what it calculated inside, and it adjusts it with the size of eventual separators between groups. So the main idea is to travel as far as possible from group to group before backtracking, and once the class has collected all this information, it's time to, it will know how big frames have to be, and also how much space their content actually needs. And that's the time to calculate object position. The trick to calculate object position consists in going in the opposite direction of depth-first search algorithm. Indeed, this time we know already the size of frames and also how much space their content actually needs. So the class starts adapting the content to the external size and calculating the position of groups, considering their alignments. So this time we go deep on each branch as before, but at each recursion the class starts from the external size and position and adapt internal size and position to it. I said before that one of our problems was the several layout problems. How did we solve it in the new mechanism? We create different versions of the same group and we put it into the script. and they can be activated by switches. So little by little, I said before that the users select, for example, the transaction, then the portfolios, the asset kind, and based on each user choice, some switches will turn on, some other will turn off, and the desired layout will show up. Switches also set fields like visible or not visible or gray. So, time for a demo. This is a holding which represents the situation of financial instruments in a portfolio at a certain time. A holding consists of a transaction, which are some events that occurred to that holding in the past or some future events calculated by our software based on some conditions. And for example, in this case, we have an acquisition, coupon payment, sale cash, and redemption. I created for this demo a mechanism which split the available space into two parts. So in the left part of the screen, we will continue to see the transaction, but in the right part, we will see a page screen with just a few fields to show values related to each transaction. And I did this for the old mechanism and for the new one to compare the differences. It will be just a simplified screen, just with a few fields. So let's start from the old one. Do you see it on the back? Okay. So this is the old mechanism. If I move this separator, this splitter, everything remains exactly how it was before. Nothing happened. And if the space becomes small and small and smaller, I will not be able to see anymore all the fields, because the space will be not enough. And it's not that really the space is not enough, it's just that nothing is happening, because it's everything rigid. So you can understand that we couldn't continue to work like this with new monitors. And so let's see the other one. Okay, apparently it looks like the other one, but if I move the splitter, every movement I trigger to the splitter, the class recalculates all the fields, position, and size. So it arranges again fields considering the available space and the script. So if the screen became small and really small, probably I will not have the best layout ever, but I will still be able to see all the fields. Furthermore, if I change transaction, I will just see other fields, because maybe I don't need the same fields for each transaction. So changing transaction, I just see different fields. Now, before to have a look to the script, maybe it's better if I explain a little bit how I organized my space into the script. I used some rulers because I wanted to push the fields in the upper part of the screen. And so I used a horizontal ruler. And then I used a vertical one because I wanted to avoid a tie alignment on the left. So there's a horizontal ruler here and a vertical one. So I just created a frame that goes like this. And I have organized the fields into 4 groups. So I have a group with all the info related to the transaction. So transaction description, status, and dates. another group for the bank information, another for the values, and another one for the fees. And these 4 groups are on 2 lines. And I have some switches that are related to the transaction, and that's why if I change transaction, the layout changes. So let's have a look to the script. So first of all, I have defined the switches. So there are 4, just for the 4 transactions, but this is just a simplified case. Then I've defined all the fields of the screen, declaring just their minimal number of characters. And then I specify the ruler that I was talking before, that are more than the default ruler of the class. These are just function of the available space. So this is a constant, and this is just a function. And I have used them to define my frame that goes from the top to h-mid, and from edge to right. And then I describe the content of the frame, putting the 2 groups on a line, and then 2 other on another line, that the new line starts from the semicolon. And then I describe the content of the fields, or the content of the groups, which is made of fields, separator, and alignments. I can use some kind of separators, which corresponds to a certain number of pixels. And then I have some vertical alignment, which are up, center, down field, and horizontal alignment, which are left, center, right field. And then using this separator and alignments, I just describe the content of each group. So let's see maybe what happens if I trigger some change to this script. For example, maybe I don't want anymore that it goes from top to h-mid and from edge to right, but I want that all the fields try to occupy all the available space. So I don't want anymore to use these 2 rulers. I want that it goes from top to bottom and from left to right. And to maximize the effect, maybe I don't want that these 2 groups are centered, but I want that they are aligned on the bottom of the page. So let's see how it changes. So this is what I had before, and this is what I changed right now in the script. So I don't have any more any frame. And the fields are just trying to occupy all the space. So if I change transaction, this is still happening, because the class is just to consider what I put into the script. So let's see now what does it happen if I change something else. For example, I say that I want that some groups are really big, because they were just aligned to the top and to the bottom, so I just want to enlarge them. And maybe I want here that this is aligned on the right. So let's see what happened now. Maybe I will enlarge also the fields of this group to maximize the effect. Okay. Let's see now what happened. This is what I had before, and this is what I have now. So the two groups on the first line are really enlarged, and the two other are pushed in the angle. And if this time, since I told to these fields that they need to be really large, if I enlarge the screen, they will still occupy all the space. So I will have just a huge effect on the screen. And still, if it becomes really small, it still will work. It changed because I changed the transaction. But yeah, that's how this mechanism works. So let's go back to the presentation. This is just a curiosity. I used for this presentation Microsoft's way and not PowerPoint. As way adapt to fit the device that it's viewed on, no matter the size or the resolution. So that's exactly what our class does. And so formatting is no longer a problem. So I would say that there is an easy proportion. The class is to all the mechanism as Sway is to PowerPoint. So we finally set Sofia free from rigidity bonds, giving her some new colors and youth. And that's all.